today we're going to go over actual real use cases that our customers had during the course of SignalWire's history and how we help them solve the various problems. We'll start with a quick overview. So first of all, this is the presentation URL. All of the slides are in there, and also all of the links that you see are in there. So you don't need to copy code or figure out things. Just go there. I'll go back to here later, but for now, it's here it is. And following that, just a quick introduction to Lamel. So Lamel, our legacy amicable markup language, used to be another word, but amicable is more fun and it's friendly, is a industry-compatible REST and XML API offering that resembles some other XML APIs you might be used to seeing from other people who are less cool than us. The SDKs are available in Ruby, JavaScript, Python, PHP, and C#, and I actually have one example for each one of the languages on the list, so that's going to be exciting. It's suited to applications that do not require high interaction. What I'm saying is that in some cases, when you have an application that has a lot of different interactions, think about the smart bot that one of our customers is using to place orders to restaurants that do not have, they're not signed up to any of the web-based tools that allow them to take orders. They step in and just call the restaurants and place order using a highly intelligent chatbot. That kind of interaction is better suited to our newer API, which is going to be featured in our next webinars, and we already did a couple. But for now, let's focus on what Lamel is. So it's just an XML language. There's an introduction on the link that I have down there, and in general, it's pretty simple to move around. It's either returning XML to have the call do something, or it's do a REST call to have something happen, such as place a call or send a message. So there we go. This presentation actually probably pretty short in the slides department, because I'd like to go through the code, because that's where the meat is. SIP-based outbound contact center in Ruby and SIP.js. This started out from a customer that wanted to dial out to their destination customers. Well, sorry for the repetition, but they wanted to dial out to their customers, but they'd like the connection to the agent to be as quick as possible. Of course, if you dialed out to customers and then they don't answer, you don't want to have an agent on the line for nothing. But on the other hand, if you wait for the customer to answer before you connect your agent, the customer will end up waiting for the agent to connect, because there are two calls involved. One goes out to the customer, the other goes out to the agent. And if you wait for the customer to answer, the agent will not be there by the time the agent joins. So how we solve this is by placing outbound calls at the same time to the customers and to the agents. So one each. They're both placed in a conference as soon as they answer. So whoever answers first waits for the other. But since the dial is essentially synchronous, and the SIP client that the agent is using is usually a little bit faster than going over the PSTN, it almost always results in the agent already being there by the time the customer joins. So they're talking to each other, and there's no delay at all. The customer doesn't even feel delay. They're just talking to the agent. Well, how we do this is setting up a SIP.js client to auto-answer call. So we have a browser page that's included in the demo, and we'll go take a look, that actually receives a call and answers right away. Of course, you can do many other things with SIP.js, but for now, that's what we're going to do in this demo. It's actually what the customer does too. So let's go to so Spotify is not part of the presentation. Sorry. I think Chrome though will have a better if I get out of here and just go to the code example. So in the browser, I prefer showing code in the browser usually, because it's generally Chrome is a little bit okay. Let's go. So again, all of the examples are in here, so you can take a look. I'll zoom the page a little bit so we can see better. So the core of the application is going to be the server.rb file. To run the application, it's pretty simple. It's a standard Ruby app based on Sinatra. So first of all, you configure your application by copying m.example to a .m file and just putting in whatever you need. You see, as you see, you need a project key, a token, a space, a name, from number, domain, and a SIP client domain. All of this is just stuff that you'll get from your dashboard in SignalWire. There's guides about this, and we can get back to this if you need. But for now, I'd like to look at the code because it's generally more interesting. So how things go here is that we set up a very, very simple Sinatra app. For people that are not familiar with Sinatra, Sinatra is a very good HTTP application micro framework you can use to power entire stacks of software, and it's very, very powerful and super self-contained. The entire application sits in here plus one index file, which is the actual JavaScript. So starting actually from the bottom, because these are utility methods that we'll go over in a bit, the /path, so just going to the application domain will get you to the client. So we'll get you the SIP client. Posting to start will call. You see there's a place call here. So what does place call do? It uses the SignalWire client to dial out to a user. So this would call what's in the two-number parameter. Two-number parameter comes in turn from the view file, which is actually just an it's the extension is ERB because it's a Ruby template, but it's actually just XML. Just HTML. So there's a form in here that we just add a few things from the HTML and send them to the backend. So what you do is we'll get the two-number from the application. What this effectively does is we're simulating the application giving the client, the agent, a list of numbers to call. So they're effectively clicking on the list and they're making a call every time. And if the customer answers, the agent is going to be dropped in the room right away. So what we do is we dial to that number. So right now the agent is logged in and they have the computer is very slow today. I'm very sorry. Taking a look at the client is going to be useful. This application is the only one that has a sizable. Well, this decides if it likes me or not. So what we do here is we'll place the call to that number. So that's the client. That will be the customer. When a customer answers, at the same time, as you can see, we'll build a SIP target. So the SIP.js client is registered using the SignalWire SIP infrastructure, which is also part of another tutorial. And this is the this will be the URL to dial it. So params to SIP, which we again get from the form here to SIP. So the username, and we'll send it to the server, and then we just dial the client domain that we set up in the environment. Effectively, this results in one call being placed to a phone number and one call being placed to a SIP target. But what does this actually do for the SIP targets? Let's go see what place call does. The important thing is that we'll of course call the two number. That's obvious. We'll dial each one of the destinations. Then we'll use the from number we put in the environment file as our caller ID. Of course, this can be any number you have on your SignalWire account, whether it's the ID you own or the ID you have verified. So this, for example, right now we're using just one number to make sure that things are working. And we'll dial out using the app domain. Why do we need to know the app domain? So SignalWire will place a webhook call to that domain and the join URL that you attach at the end to fetch the XML that we're generating for the call. So it needs to know the absolute domain. If you're testing locally, as the guide says, what I will recommend is using ngrok. Ngrok is a simple tunneling tool that's free and allows you to get a domain that actually points at a port on your application, on your computer. So for example, if I wanted to do this I'll just do this for the Ruby example. It's the others generally use the same thing. I don't know what's going on here with the console. So, but anyways, as soon as it wakes up, we'll get it going. The idea here is that when that join URL is reached by SignalWire, we'll generate what called the enter conference endpoint, which in turn will just generate a dial to a conference. Dialing to a conference is very simple and is generally so all we do is dial a room, a name that for a room. As you can see, we just named that room 1234. It doesn't really matter here. Of course, in a actual production setting, you probably want to give it a name that actually looks like it's properly set up. Something, I mean, a name for a different conference. Of course, if you join more people to the same conference, they'll effectively end up in the same place. So conferences have to have the have to have different names. Just to take a look at a quick Lamel example here. Here's how you dial into a conference. It's just dial conference room 1234. This is straight from the examples. You can do. There's a few other options you can set up for the room in general, but it's going to work. So okay, going back to what this does. I wanted to do the ngrok thing here. So ngrok, I have a paid for account because I use it so much. So as a result, I can do a few things just such as have my own domain. It doesn't really matter. You get a random one, which is absolutely fine. And there we go. As you can see, this page is served straight from the application. And all I need to do is run the, is connect. So I have an account set up here. So I just want to show you the whole thing because this is probably the more complicated of the examples. So to log in there, I will go to my dashboard and create a SignalWire endpoint. That will be a SIP user. So this is configured as my main domain, web SIP, and the password is whatever password it is. And we can log in right now. I don't remember the password. Got it right. Okay, then we'll go and copy my destination number, which unfortunately I never remember by memory. This is actually the number I use for everything. And I'll dial out here and I'll bring Bria over so we can see what's happening. This is just a registered point. Okay, so this is going to play the role of our customer. This is going to be the logs in the background. This is going to play the role of our customer, and this is going to play the role of our agent. So the agent is now clicking on a number on their screen and just placing a call. My phone is ringing. I answer, and now you can't really hear it because of the echo, but it's working. So I'll hang up the call. The two ends didn't have any delay at all. There's a few settings we should add to make things more comfortable, such as making the conference end when one of the parties leaves, but that's really not that important. I mean, it's important for a production, but doesn't add or detract anything from the tutorial. So again, this is composed of an HTML page that serves the client and a simple Ruby server. And if you add a few database calls here and there, you have a working outbound call center with no delay between getting connected and talking to an agent, which is actually pretty important and I think quite cool. So that will be the first example. That will be Ruby. So originally, we only had 3 languages scheduled, but there's 5. How about that? Cool. So next in line. If anybody has questions, just drop them in chat as usual. I try to take a look from time to time, and we'll answer them as we work. Okay, what's up next? Node.js, outbound Surveybot. So this is an example. I actually simplified a little because the original customer has a more involved use case, which we'll go over. And I just wanted to build a quick code example. How this works is an outbound multilingual Surveybot, which I failed at changing the title there. She'll say Node.js. I'll change it. So this is Node, actually. So the customer will like to dial out to their own customers, asking them questions in this case. So the original use case is a medical questionnaire. They're generally asking people what their experience is with a medication and stuff like that. The audience can speak English or Spanish, and we need to localize prompts. So this what this will show in particular is how we use internationalization to localize prompts. And I managed to say that word once, and I won't say it again because I got it right the first time. Yay! That I think that's why we just call it I-18N. It's actually easier than saying internationalization. Wow, that was easy. So jokes aside, let's go take a look at the code. Outbound Survey is a JavaScript application. To run it, it's the usual stuff. So clone the application, run npm install, configure the application by copying the env example to .env and adding the credentials, including the application domain. Again, I recommend using ngrok, and then just run node index.js. This is actually an easier application because env example looks the same thing as the others, and the application is actually resides all in one file. Which shows how easy it is to build a quick app in any language, really, using the SignalWire SDKs. So again, this was originally conceived to ask questions to people. What we'll be doing here is we're going to ask them one question only, which is their favorite food. That will suffice as an example, and it's actually quite fun. So starting from the top, we have the usual requires. Express is the JavaScript, the Node.js web server. It's very close to Sinatra and Flask in Python and the other frameworks that we use. But in general, Express it's the most used in the Node world. REST client is the require we use to do a thing in Node, and then we require .m.config. This just loads the environment from the end file that we set up earlier. Then we set up a little bit of internationalization, including the strings for the introduction, the question, the closing, and if something happens. Sorry, actually, I'm sorry. So if I didn't translate this correctly, my Spanish is a bit rusty, but you're welcome to let me know if something looks wrong, and I'll be happy to change it. Generally speaking, though, what we have here is we go over a little bit of an advanced use case for Lamel. So going back to the Lamel XML API, XML specification, we can see how say, which is the verb we use to speak, has a lot of different options you can use with it. For example, you can use SSML, you can use simple stuff, and you can specify a language. We support many languages actually, so this is quite this is going to be quite useful. We have customers using almost all of these languages, which is quite good, I feel like. So in this case, we're going to be switching between English and Spanish. So that's what we're going to use. Gather supports other options, including specifying properties using SSML. SSML, which we'll see again at work in the Python example, is a XML specification that allows you to specify how a word or a phrase should be spoken out. So you can do breaks, you can do emphasis, you can speak words using a phonetic pronunciation. You can change the rate of speech or the interpretation. In this case, what we're doing here is, and I left it in because it's interesting, our customer felt like the speech was slightly too fast. So what we're doing here is, aside from specifying the language, we're adding an SSML prosody property of 95%. Prosody is how fast the words are spoken. 95% means it's going to be just slightly slower than a default, which is enough. Apparently, you can do it. You can mix and match. You could have a part of the sentence being spoken slower than another part of the sentence, or you can mix and match. But the important thing is that this allows you to repeat sentences in a different way. Even we have other customers that speak the same. So if you give the wrong answer to a prompt, they will speak it back slower, which actually helps with a percentage of correct answers. In this case, we're just speaking everything in 95%. Respond and log would just print the XML to the console and then respond to the Express server. This is just setup, including setting up on port 3000, unless you set up different. This will run at all these examples, by the way, will run on Heroku with very little modifications. So if you need to do a quick deployment over there, just let me know and we'll be happy to help. Regarding the start action, so as usual, we'll give we need to give our call that we're placing. The call placing code is a little bit down. Something to do. So when we pick up a call, we do a very common pattern in Lamel IVRs. So if there's a digits response, what this means is that we'll be using a gather XML stanza here. Gather is the verb that we use to gather input. So to receive input, it's here. There's a few examples here. It supports both speech and DTMF and various properties, and we'll go over those too. But for now, let's focus on this simple example. So if we don't have a digits entry, it means nobody pressed the digit. Remember, this is DTMF only, right? So this is just DTMF. There's no speech here. Speech recognition will be using the Python example. So did someone press a digit? Yes. Did they press 1? Then they need to go to the question with English language. If they press 2, they go to the question with language in Spanish. Else, we'll just repeat the prompt. You could optionally say something here if you think something is warranted, like say, sorry, I did not understand. We repeat the intro and redirect them to the start, effectively rolling over. Otherwise, we'll just prompt them with the gather, which asks them for a digit and going up. In this case, we'll see we play them both because we don't really know if they speak English or Spanish right now. So we'll say, hello, we have some question from you. Press 1 for English, or hola, and I won't butcher this because I have respect for my Spanish friends. And I'll say, press 2 for Spanish. The result will be if we press 1 or 2, you get to question with the appropriate language set. First of all, we'll pick the language out of the query string. Then we'll check if there's a speech result, because our speech result is what contains the result of a speech gather. If there's no speech gather yet, we'll ask for the gather. So every action process its own input. If there's no input yet, it will ask for it. If there's input, it will process it. So let's first start from here. Gather, input, speech timeout, auto. We just let them say whatever they want. The question is, what's your favorite food? And then we'll say it with options, and we'll go back to, and we'll wait for them to say something. When they say something, speech result will be populated, and we'll just say, if they say hamburgers, we'll say, hey, hamburgers. And the closing message will just say, that sounds delicious. So this should be sorry. I'll change that later. So we'll say sorry if we don't understand. How do we trigger a call to? Of course, this could be used for really anything. Again, our customer uses this, not using DTMF. Actually, they use speech input because they then perform the matching themselves with what people say using their own sentiment analysis. So the actual question is something like, hey, how are you doing with your new medication? and the person will say something, yeah, it's doing great, but I have headaches from time to time. And they'll run that through a specialized engine they use to make sure to understand if the person is having problems or not. Because generally speaking, as they let me know when we discuss the project, it looks like just asking people for a yes or no answer when it comes to medical stuff is never the right approach, because they generally will say yes just to be left alone unless something is very wrong. Or you have people that will always say no matter what. Asking them for a discursive answer will help really understand what they're actually feeling. In this case, we're just asking them for their favorite food, which is a much more fun thing to do, in my opinion. How do we call them to ask them for their favorite food? Well, in this case, I set it up using an application endpoint. So you do a post to the trigger endpoint, passing in a two-number parameter, and it will create a call the same way we saw in the Ruby application. You see a pattern here because they really all look the same, and they will call the two-number we pass in using the SignalWire from number we set up in the env for a caller ID, and then we'll dial them. And when they answer, they'll be dropped into the domain/start URL. If you remember, domain/start URL will drop them into the menu that asks them if they speak English or Spanish, and then go through the various entries. So if they say they press 1, they go to the question that's just an open-ended question using speech recognition. So this displays how easy it is to make a multilingual IVR or application using Lamel. Just use it's all of this, by the way, is not really secret sauce. It's good architecture and quite a bit of plain old JavaScript objects. There's no magic here, aside from the SignalWire magic that makes it all work with the speech recognition and all the other things. Cool. So this was the JavaScript application, which comes from a real life use case. Let's go to another real life use case, which is going to be quite interesting. So when I sat down to find an example in I don't even know how many examples I've wrote over the course of a couple of years, but when I sat down to figure out what could be a good use of Python language to do something different, I figured out that recently we had to help out a customer that was building an application that will do the same thing, so perform the same actions, both on SMS and on voice. So what I did here is reduce it to a single page thing that allows a customer to check their balance and find out when their next credit card payment is due using voice and SMS. And as a bonus, it's speaking back the currency and dates using the correct XML. The idea here is that the speaking back numbers and especially dates using pure text to speech generally doesn't work and ends up saying weird stuff like 02152021 or stuff like that. So what you want to do here is use the correct pronunciation, and I'll show you how. There's a little trick actually you need to use because of how Flask, the the Python micro framework we use here, is treating responses. But we'll see it in just a second. If Chrome collaborates just a bit. So what we have here is a multi-channel IVR. Again, this is quite simple. Oh, I need to go delete that. Well, no problem. This is quite simple. It's got a few simple requirements. Just pip install requirements.txt. Please use your virtual env. It's usually a very good idea, but anybody using Python knows how to do that. Then export this variable. This is slightly different and sometimes still gets me. So make sure you export the Flask app variable or the application will not run. And then you run Flask run to actually bring the application up. Again, you can use ngrok, and then you'll set up your SignalWire DID to point at your ngrok domain voice for voice calls and your ngrok domain SMS for messaging. Let's go quickly see how that looks like, so we're not caught by surprise. I think this is the number I was using earlier. Oh, well, okay. So this will look like something Lucas MVP ngrok IO. And this will be voice, because you see we're handling the voice calls here. And then we'll Lamel, Webhooks, and SMS here. So as you can see, I've set up my phone number to take calls on that URL, voice for voice calls, and that URL for SMS on SMS. You could actually use the same endpoint for both because messages have a body field while phone calls don't have a body field. But it's probably, in my opinion, it's too much work. It's better just have it set up like this. So voice calls, Lamel webhooks, voice call, messaging, Lamel webhooks, and Grok SMS. All of our numbers are currently both voice and messaging capable, so you can just set this up on any of the SignalWire D80s. Going back to the code, taking a look. This is also a pretty simple single-page app. Well, it's not technically a single-page app, sorry, it's a single-file app. It starts out with a few imports, including the Flask, of course, stuff we need to run, the things. Flask is again, a web micro framework in the same vein as Sinatra and Express. Sorry, I've seen so many these days that I mix up the names. Flask is the Python one. And you import messaging response and all the various stuff you need from the SignalWire framework. I set up a couple very simple helper methods. These, of course, should be some kind of a database lookup, right? Because I know who you are because I know your phone number, and by that I should be able to retrieve your balance and credit card. To not clutter the application, I've made this static, but this should actually be some kind of a database lookup. So first of all, message comes in. I get the body and check for the I get the body from the request form. Okay, so now what we're setting up here is again the same pattern of looking for an input. So let's start from the bottom. If we have no input here, we will say, please enter your PIN followed by your command. For example, 1234 balance or 1234 credit. This is secure enough. In a production application, what I will do is probably write down that phone number 1404, etc., has entered their PIN correctly and is now enabled to send commands for a few minutes or something like that. This works though. Like I've seen this done in actual applications. So, of course, the PIN here is super secure because we literally check against the string. Again, this line 19 and line 21 should be deeper database checks or something like that. But just, of course, anything that's just an if can be turned into something far more complicated. So leave that as the for your application application logic. But what's important here is that if they're asking for the balance and the PIN is correct, we'll respond with your balance is, and we'll get the balance from there. If the message body is 1234 credit, your credit card is due, and we'll send this back. All this is all you need for a user to have a meaningful interaction with your application. Adding database challenges here really makes it so it's actually working, which is quite cool. Voice is slightly more complicated, but not by much. What we'll do here is usual pattern, get the speech and digits. In this case, we'd like to get the speech and digits. So let me first explain a few things. If you do input speech DTMF, the timeout of 5, num digits of 4, like here, if the user says their PIN in voice 1234, you actually get back the correct list of digits. So you don't need to do any conversion. It will just try to turn digits into numbers as much as it can. Or otherwise, if the user has entered the PIN using pressing DTMF, they will get you the 4 digits because you asked for 4, and the system will wait until they press all 4 or time out in 5 seconds if they don't enter them. Of course, in that case, it won't match, and it'll go back to the start. Let's see where the next step is. So take a look at this. If we got the correct PIN, we'll send them to ask. Again, there should be something where you save that call said blah blah or phone number blah blah is allowed to ask for it, because this will not be secure in a pure banking environment, but it's good enough to get things going when you're looking at things. Adding ifs and database hits is always possible. Sorry. So we go to ask, and we find out that all we do is just gather an input of 1 digit or speech. This is pretty important. And we're asking them to say balance or press 1 for your balance, say credit or press 2 for your credit card due date. This is the classic multi-channel, multi-method menu. So whether they say one or they say one, whether they say balance or press one or vice versa, you get the right input. So we'll go to perform when the gather ends. So when gather thinks it has collected some input, whatever it is, we'll go to perform and you will try to interpret it. We'll grab the various things, and then if they say balance or they pressed one, we'll say your balance is placeholder. Dun dun dun. What's that? Back to that in a second. And we'll actually set up a replacement string here. And as you can see, it's using say as, interpret as SSML entry to have the string that's inside the say as tag interpret as a currency. If they press 2 instead, or set credit, we'll say your credit card is due. Again, this mysterious placeholder. And then set up another say as tag. This time, it's helping us interpret the output, as a date. Format is MDY, just so we're sure that it got spoken correctly. But generally speaking, that will be the default if it's formatted like it's up there. So if it's formatted like this, it will say it correctly, but it's always better to specify the format. And then we'll just get that static string. If they didn't say balance, press 1, say credit, or press 2, they'll go to, we'll redirect them to ask and ask again. This could be a sorry or something, but for now, it's just that. Okay, so line 68 is actually the interesting line here. What happens here is that so far we'll be using return response to XML, which is what the Flask framework requires in Python for us to give it the output it needs to display on the action. Unfortunately, that toXML method, when passed through the Flask piping, so to speak, turns the so see there's some HTML symbols in here, XML symbols in here. It will turn all of these into HTML entities to escape them from the XML. This results in a non-valid document. So instead of hearing your balance is $50, you'll hear something here. Your balance is say as, interpret as currency, which is sort of weird. It's very weird. So the only way to get this to work in Flask without doing deeper changes, we will not have fit in the one page of code idea that I had in mind, is just generate the XML. At this point here, we just have a string. It's a normal string. Just go replace that placeholder string with the replacement. Of course, if placeholder means something to you or you run a risk of it already being in the string, just use something different, but it will always work. Cool. So again, one more time, SMS is self-contained. If they write us 1, 2, 3, 4 balance, we'll just send them the balance. Or credit card. Voice is a little bit more involved, but not by much. We'll wait for them to either say 1, 2, 3, 4 or enter 1, 2, 3, 4 in digits. And then if it's correct, we'll ask them to say balance or press 1 or say credit or press 2 and then act accordingly. All of this is multi-channel. So you're using the same data. So the same balance and same credit card due date are used in the both SMS and voice channels. And it's also multi-input. So you can do input both in voice and in text and in DTMF. I find this actually quite useful. And most of these patterns are going to be recurring in your applications. So you can take what you see here and take a little bit of what you saw in the Ruby one, a little bit of what you saw in the JavaScript one, and apply it to your own apps. So we started late, so I think we do have a few more minutes. So let's go to the bonus part. Yay. So this was supposed to be 3 applications today. But my idea was, why don't I just do all of the languages so that looks like we're trying to help everyone, which is important. And the bonus app is a PHP call screening and voicemail application. This was this is the first bonus. We have a double bonus today. So what we want to do here is screen an incoming call by speaking the number and allowing the user to reject the call. So I have a DID set up that's not my cell phone, and I want to make sure that anybody that's calling me I want to speak to This especially works for desk phones that are not SIP. So I don't have caller ID. It's an older phone. I don't know. So what happens here is that when I get the call, while the other end is just hearing ringing, I hear a message that asks me if I want to take the call. So I will press 1 to take the call or hang up to reject the call. If I don't answer at all, or if I reject the call, I would like the call to go to voicemail so that I still get the message. In the odd case, it was something important. Here's how it's built. This is actually pretty interesting. This is another real life use case that we have a customer using. Code, PHP voicemail. This uses, just so we can take a quick look, this uses a framework called Slim. The Slim framework in PHP is yet another lightweight micro framework for web apps. This time it's for PHP. I recommend using all of these micro frameworks in their respective languages for ease of use and getting started quickly. It's generally quite a bit. It's generally quite a bit better than spinning up a full-fledged web app and then figuring out your missing parts. So this is again just a single. Just a single thing. And here's how it goes. So we need a couple PSR. So PSR is a kind of a PHP extension thing. A couple PSR extensions, a Slim factory, and then we'll use the Lamel voice response here. Odalog is just standard boilerplate, and then this looks yet another micro framework app. So we have an index action. This is actually sort of complicated to follow, so it's quite it is quite interesting actually. What we do here is we set up a Lamel action that dials a phone number. The 2 numbers should be my phone number, and when I answer, I will go to the URL of screen, while the dial verb, which we can see here, also has its own action URL. The action URL will be called after the dial call ends. This is important here because this will be called when the dial call ends. So when the leg that goes to me, and then when I decide if I want to talk to the other person or not, that call will go to the voicemail endpoint. Okay, so now I answer my phone and I get dropped into the screen action. Screen action is really just asking me for a digit, and it goes to connect if I press 1, and it will say, you have a call from post from. It will read me the message. It's a phone number. I think in this particular case, the SSML to say the phone number is not needed because it will be recognized by itself, and press any digit to accept the call. So no matter what I press, the call will go to the connect action, or I can just wait or hang up. When the gather times out, the system will tell me hanging up and then hang up. So keep this in mind. In this scenario, we have a fork in the road here. In this scenario, I haven't answered, and the other end should be sent to voicemail. Scenario 1, I did press a key, and now I'm talking to them. Connect, which happens when I press 1, will just send me to, will say connecting you. This is something I put in just to make it do something. Really, this action should be an empty response, but having it say something, it's actually cool, and say, okay, connecting you. Past this, I'm talking to the person. So final part, remember we have a dial up here that is dialing with an action of voicemail. So this call was my phone ringing. Whether I don't answer the call at all, or whether I don't press a key, this will drop through to voicemail either way, but it will also drop through to voicemail if I hang up after having spoken to the person, which is something it shouldn't be. So we need to detect that the call was not actually connected. Luckily, it's pretty easy. If the call has a dial call status that's different from completed, it means me and the other end didn't talk to each other. No matter what happened there, I either didn't pick up or I didn't press one or a digit after it got connected, this won't be completed because we didn't talk to each other. So in that case, we'll say to the caller, please leave a message after the beep and press the pound key when done. They record the message, and then after the recording happens, it will be sent. There will be a post to the store action. Store action is just showed there for completeness. This is where you'd store your recording somewhere. You get a recording URL and you do something with it. Of course, I commented it out because I couldn't think of anything to do with it. And then we're just sending back an empty response. So we dial ourselves. So call comes into our screening DID. I get a phone call on my phone number, and I decide to screen if I want to talk to the person or not. If I don't want to talk to the person, I will not press one or I will hang up. So there's a question that's what's voicemail in SignalWire terms? SignalWire terms is not really voicemail. What you see here is recording a message. Voicemail can be easily built out of the SignalWire Lamel primitives, but we don't really provide voicemail by itself. This is a recording tool, so this actually works. You get a post to your endpoint that will tell you who the call was from and what the recording contents are, so you're free to save those to a database, turning that into a proper voicemail thing. Voicemail is, I understand voicemail in PBX parlance is something, but here we're just referring to recording a message and then storing it somewhere. Keep in mind, this is a cloud-based API, not a PBX. So you can build very good PBXs around here. The example we just saw, we have many customers operating large applications out of this example of variation of this. So call screening, etc. That makes it pretty interesting. Last but not least, and we'll just be a little bit late today, is the double bonus, which is a C# simple IVR example. It allows user to press 1 support and 2 for sales. It's a quick example using ASP.NET Core, which was actually quite complicated to set up for myself because I just learned C#. So yeah, this application works and I'm very happy about it. It can probably be done better in a million ways, but I think the complete example would be helpful for people just starting out because it is a self-contained application that will run on your command line without any other addition and will work as a simple IVR. Of course, you can just do it something more complicated in your code if you like, but this is a good starting point. Sometimes starting out is harder than the actual coding once you get into the gist of it. Again, IVRs do have a few recurring patterns as you've seen, such as checking for input or asking for input, and those are cross-platform. Like every language has a way of doing that. Let's go see how this looks like because I'm very proud of it, even if it's not really super duper great. So C# people in the audience will want to probably suggest a better way to do things. I'll be happy to oblige. So what you can see here is that setting up a C# project is somewhat a little bit complicated because it needs a few different things. So .NET Restore, .NET Run. Of course, the general stuff here is that C# app is a compiled application that's based on a large enterprise framework. So it does need a little bit more of code. Mostly the startup stuff here, which configures the application. This is not boilerplate, but it's pretty close to boilerplate. And the program stuff here, which does the includes, again, this is mostly boilerplate. The important thing is that once you've used the .NET Web API Quick Start to set up your application, all you need to do is go to your controllers folder and add your first controller. So really all the code is in here. ASP.NET Core has a very interesting way of setting up applications because every controller is supposed to only have a single action per HTTP verb. So what we're doing here is we're using get to send the XML and using the post version of the same action to perform the requested action. It's pretty simple. Pretty simple once you get it going. So how this works here is we'll set up a result. Again, gather, usual gather of 1 digit, timeout 5. we're asking people to say +1 for sales or 2 for support and appending that to the response. Then just returning it using a helper, which you'll, well, and the the digits stuff. So when we, of course, then we'll get input. Input will go to the post because we're setting it up to go to API voice and we're not specifying a method. So we go to post. We'll check for the request form digits value, usual pattern. Is there a 1? Yeah, connecting you to sales. New dial number, that's whatever sales number it is. Digits 2, connecting you to support. Again, dial. Else, we say, sorry, the choice is invalid, and then redirect them to the URL API voice using the get method this time. It's pretty straightforward. I know it's not as interesting as the other apps, but I just learned C# and I'm pretty proud of myself. Then again, I'd be happy if people from the audience would like to suggest better ways to do this. But this is pretty close to a micro framework type of application in C#, which again allows you to experiment with the various things that are in the SignalWire API and build very good applications without too much work. Okay, so this concludes my whirlwind tour of 5, count them, 1 per language, real-life applications, well, 4 real-life applications. Still, you could make a case that many IVRs are just press 1 for sales and press 2 for support, or vice versa. So that might still be a real-life application somewhere out there. The goal here was to show you a few patterns, link you to the code. I understand that in an hour, it's better to just go and read the code again. But the goal is to show you how there's overlapping patterns that allow you to build complicated application pretty simply around Lamel. One of the applications even has a WebRTC based zip client that allows you to deploy a distributed call center in probably hours. And that's a very, very powerful application and very powerful use case, in my opinion. What's coming next? Well, there's 2 main things. One is Relay, our JSON-based real-time call control protocol that's revolutionary in many ways. We've done a couple webinars, and please join our next webinars because we'll uncover a little bit more of Relay, what's in store, etc. And the other big thing that's coming is SignalWire Work, which is our video API. It's already available in a beta slash a release candidate version for select customers, and this API is going to be very, very useful. And we'll go back to this in a following presentation. So that concludes my presentation for today. I think we more or less stayed within time with time for questions, and I understand there's a lot to process. So again, first of all, I'll go back to the presentation URL in case you want to write this down, and I'll also put this into the chat so people can just click on it. A presentation in turn has the links to all of the other files, so you don't need to write down anything other than this URL. And I thank you for joining us today. And if there's any questions I can answer, I'll be happy to. Otherwise, I'm looking forward to seeing you online for the next webinar, which is going to be, I think, February 15th, but we'll send out an email and will be about real-life Relay use case built around a very interesting business case. Thank you so much. The samples in different languages. Each sample is in a different language. No, they don't. I mean, there's no different version of each sample in different languages yet. Of course, you don't need to use many languages. You can use one. It's just most of the things actually carry over once you get the gist of it. If there's any particular example you see that's in a language you don't like, I will. I'll be happy to help. Regarding Lamel API is all synchronous calls for the most part. There's 2 new features that are coach and async recording that are going to be. I think they're either released or going to be, but you know about it when we do we'll send out an email when they are. You can do some of the async stuff by doing what's called an update. So you can send an update to the put method to a call SID to call ID, and have that do something different than the Lamel is currently using. But if you're looking for true programming, true async stuff, you'll want to use Relay, which is our next generation call control protocol, which adds all the synchronous stuff you can think of, and more. So Lamel has some async capabilities, probably enough to build medium complexity applications. But if you need a lot of async, you will definitely want to use Relay, and you definitely want to tune in 2 weeks. Oh, Relay is already released. You can start using it right now. It's just we already did a few presentations, and which are on our YouTube channel. And of course, you're welcome to take a look and tune in again, and we'll go over a few things again. It's already out there. Thank you so much. And thank you for joining us today. And I'll be happy to see you again in 2 weeks for the Relay use case presentation and for all the others. Remember, there's also ClueCon coming up. We'll go ClueCon Deconstructed coming up. We're going to have 6 workshops and 8 great presentations. And don't forget to go sign up at ClueCon.com and let me know if you do. And I'll be looking forward to seeing you there. I'll be running the FreeSwitch workshop and the SignalWire Cloud workshop. Thank you so much and have a great day.